Well, today we're going to look at properties of exponents. So properties of exponents. Okay. Now we're going to look at more specifically 7 of these properties. Okay. So if A and B are real numbers, so we're going to look at, let's let A and B be real numbers, and M and N are integers. M and N are integers. Then we have these 7 properties, okay? The first one is called the product of power properties, okay? The product of powers property. So if you have a to the m times a to the n, that is equivalent to a to the m plus n. The next one is the a to the m to the n, so this is power of a power property. It's a to the m times n. Okay, the next one is power of a product. So you have a times b to the m is equivalent to a to the m times b to the m. Okay. Next one's called the negative exponent property. So a to the negative m by definition is 1 over a to the m. Okay, we got the zero exponent property. So if you have a to the 0, anything to the 0 power is 1. Of course, a cannot be 0 here. You have a quotient of powers property, quotient of powers property. So if you have a to the m, it's an m, over a to the n, that is a to the m minus n. And finally, the power of a quotient property. So let's go a over b to the m is a to the m over b to the m. Okay, so let's look at some examples now. In evaluating numerical expressions here. Let's first one. Let's go 7 to the 6th over 7 to the 3rd. Okay. So this one here, we're looking. You notice that they have the same base of 7 here. The quotient of powers property is the one that we're going to apply here. So using the property, this would be 7 to the 6th minus 3, or 7 to the 3rd, which is 343. 7 times 7 times 7. Okay, and this is pretty intuitive actually, because you know, what does 7 to the 6th mean? Well, it means you got 7 times 7 times 7, 6 times, right? You have 6 sevens. On the bottom you got 1, 2, 3. 7 over 7 is 1, 7 over 7 1, 7 over 7 1s. You see that 7 to the 3rd there? 7 times 7 times 7 is 343. Okay, so you could also look at it that way if you didn't want to apply the quotient of powers property. Let's do another one. How about 3 to the negative 2? Well, by definition, you have, that is the negative exponent property here. You have, that's 1 over 3 squared. Or 1 over 3 times 3, which is 1 over 9. Okay. Probably remember that one. Let's do another one. How about 3 or 2 to the 3rd squared? Okay. Well, this is a power of a power property. So those two right there, you're going to be multiplying those. So that is 2 to the 6th. Okay, 2 to the 6th, or 2 times 2 times 2, 2 times 2 times 2, or so that's 8. That's 8, so you got 64 here. Okay, and you can always look at the meaning of this. You know, 2 to the 3rd, 2 to the 3rd squared, that means you have 2 to the 3rds, don't you? So 2 times 2 times 2, 2 times 2 times 2. In other words, 2 to the 6th, which we already said was 64. 64. Okay. Let's contrast that. Now that was 2 to the 3rd squared um, what would 2 to the third times 2 squared be? So this is now looking at product of powers. Product of powers. You know, notice their bases are the same, right? So applying the product of powers property, you can say, well, that's 2 to the third, 3 plus 2. In other words, 2 to the fifth, which of course is 32. If you want to write it out, you can write it out here. See how you got 8 there, 8 times 4, 32, right? 32. But another, you can always go back to, well, by definition, what does this mean? Well, 2 to the third is 2 times 2 times 2, right? 2 squared is just 2 times 2. Well, how many of those do you got? You got 5 of those puppies, which we already said was 32. Okay? That's a little bit of evaluating numerical expressions. What about if you're simplifying some algebraic expressions now? So let's say your algebraic expression, you have x to the negative 3 over y squared. All of this is to the fourth, okay? Well, first of all, you want to say, let's apply the power of a quotient property. So the 4 is going to apply to not only the top, so x to negative 3 is going to be to the fourth, but also your denominator there, so your y squared is going to be to the fourth. Okay, so power of a quotient property. Now right here, you're going to multiply those. Same thing down there. Okay, so you got x to the negative 12 all over y to the 8. That would be your power of a power property there. Now notice that you have x to a negative exponent, x to the negative 12, right? Well, this, by definition, is 1 over x to the 12th. In other words, what it's going to do is it's going to shoot it down to the bottom, because x to the negative 12th is the same as 1 over x to the 12th, okay? So you got 1 over, and you take that x to the 12th to the bottom there, and you got that y to the 8th still, okay? Let's run through a few more of these. How about this next one here? You got negative 3a. Let's take that to the third times a to the ninth times a to the negative 7th. Okay. And then here we go. Let's see. What does that give us? Well, we got a power of a product. So that to the third pertains to not only the negative 3, but also to the a. Okay, so this becomes negative 3 to the third, a to the third, a to the ninth, a to the negative 7th, right? Well, negative 3 to the third, that's negative 3 times negative 3 times negative 3, or negative 27. You got a to the third times a to the ninth. So that's a, if you're going to do both of those, how many a's you got there? Well, 3 plus 9, 12. Looks like I got 12 a's, a to the 12th, and you got a to the negative 7. Well, that becomes, you notice this a to the negative 7th. A to the negative 7th, a negative exponent property, that's 1 over a to the 7th. So you got negative 27. In other words, that shoots it down to the bottom there. Times 1 over a to the 7th. So a to the 7th goes down to the bottom. Well, if you have 12 a's on top, you got 7 on the bottom, how many are you going to be left with on top? 5, right? 12 minus 7 is 5. So this becomes negative 27 a to the 5th. Let's go c to the 4th d, quantity squared, all over c to the ninth d squared, c to the ninth d squared. Okay? So first, that squared, again, is going to pertain, that is a power of a product. So that 2 pertains to the c to the fourth and the d. So you got c to the fourth squared, d squared. All right, so this is only fair. And we got on the bottom here c to the ninth d squared. Right? Well, c to the fourth squared, you're going to multiply those two right there. You got c to the eighth. You got 8 c's right there. And you got d squared. And on the bottom, you got c to the ninth d squared. Right? So if you got 8 c's on the top, you got 9 c's on the bottom, you're going to be left over with 1 c on the bottom, right? Or if you're unsure, you can always write it out. You know, it's kind of annoying, but you can do that. 1, 2, 3, 4, 5, 6, 7, 8. You got 2 D's, right? Bottom, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 D's. Cancel, cancel all those. You're left with 1 C on the bottom. And of course, what do you leave on the top? Well, you leave a 1 because it's 1 times all this. But we just don't ever bother to write that 1, do we? So 1 over C. Okay. So that's a little bit with simplifying some algebraic expressions. Let's just do a quick example here. Let's say that an example here in my notes. Let's say Greenland covers approximately 2.2 times 10 to the sixth square kilometers, so kilometers squared, and has approximately 5.6 times 10 to the fourth people there in Greenland. This was a few years ago. About how many square kilometers are there per person? About how many square kilometers per person? Okay. So you want to take a look at this. You know, well, I got to take my land area, square kilometers per person, divide by the population there. So the land area, divide that by your population. So this becomes, well, my land area here is 2.2 times 10 to the 6. This microphone's a little bit annoying to hold sometimes. Divide that by the number of people. You have 5.6 times 10 to the fourth. Okay. This is square kilometers. This is number of people. Right? And now we can use our properties if we want to. So we can split this up and we're like, well, there's a multiplication here between that 2.2 and 10 to the 6. There's also multiplication on the bottom. So why don't we write this as 2.2 over 5.6, and then let's multiply that by 10 to the 6 over 10 to the fourth. You notice both of those have a base 10 there, don't they? So 2.2 divided by 5.6, let's see, that's 0.393. And then 10 to the 6th divided by 10 to the 4th, you got 6 tens on the top, 2 on the bottom, so it's 6 minus 4, you got 2 left. 10 squared on the top, right? So times 10 squared, there it is. 0.393 times 10 squared, well, 10 to the 2, so you're going to move that over if you want to look at it scientific notation or think about multiplying that 0.393 times 100. You get 39.3. There's about 39.3 or about 39 square kilometers per person in Greenland. I wonder what that is in Las Vegas. Probably about, well, much more dense than that. We'll just put it that way. Thanks for listening today. Have a good day.